How's it, grade 11s? Today we're going to look at the solutions to exercise 5, the sum of a geometric sequence. So those are the questions you had to do. Okay, let's look at question 1a. So we've got a first term there of 2/27. We've got a ratio there of 3, right? You multiply every single term by 3. And then we've got the n, which is 9, the sum of 9 terms. So therefore, Sn is equal to a r to the n minus 1 over r minus 1. So the sum of the first 9 terms is equal to a 2/27. The ratio, which is equal to 3 to the power of 9 minus 1 over the ratio, which is again 3 minus 1. So the sum of the 9 terms, you put that in your calculator. Okay, and then the sum of the first 9 terms is equal to 728,96. Question 1b. Right, so we've got the first term there is minus 64, the ratio, which is equal to -2, right? You divide every single term by negative half, you divide every single term by -2, and then you've got the number of terms, which is equal to 10. So therefore, Sn is equal to a r to the n minus 1 over r minus 1. So then the sum of the first 10 terms is a minus 64 times by the ratio, which is minus a half to the power of 10 minus 1 over minus a half minus 1. So the sum of the first 10 terms there is then, if you just type that in a calculator, minus 42.625. Okay, let's look at the question 3a. How many terms are there in the series minus 64, minus 32, minus 16, and then it goes all the way up to minus 1 over 32. So we've got a first term there that's equal to minus 64. We've got a ratio there that's equal to a half, right? So you multiply every single term by a half. Term 3 divided by term 2 is the same as term 2 divided by term 1. And we don't know what n is yet. We need to find n, and therefore, and then we can find the sum in b. So how do I find what n is? Well, we have a value of a term there. It's minus 1 over 32. So we can find the general term first. So it's a r to the n minus 1. Please don't be strange, all right? And use the general term of arithmetic sequence. Don't. So Tn is equal to a, which is minus 64. The ratio there is a half to the power of n minus 1. So it's minus 1 over 32 is equal to minus 64 times by a half to the power of n minus 1. All bells and whistles here. So what we're going to do now is we're going to divide minus 64 on both sides. We get minus 1 over 32. And then if you divide minus 64 on both sides, it's the same as multiplying by minus 1 over 64 on both sides, right? If that makes sense. So you just divide minus 64 on both sides. And we're going to get 1 over 32 times by 64. You don't need to be very good with multiplication to do this actually, because 32 is 2 to the power of 5, 64 is 2 to the power of 6. So 2 to the power of 5 times 2 to the power of 6 is 2 to the power of 11, and 2 to the power of 11 is 2048. That's double 1024. So then that is equal to half to the power of n minus 1. And then that means it's a half. You either use logs now, or you just make the bases the same. This is a half to the power of 11. It's equal to half to the power of n minus 1. Therefore, 11 is equal to n minus 1. Therefore, n is equal to 12. All right. So we know we're going to find the sum of the first 12 terms. So the first part was just to find how many terms are there. So therefore, now we need to work out what the sum of the first 12 terms are. Right, so that's in question. So question A is 12. So question B then, the sum of the first 12. That's not too bad. So it's Sn is equal to a r to the n minus 1 over r minus 1. So it's the sum of the first 12 terms. A is equal to minus 64. R is equal to a half, right, to the power of n. What is n again? There is 12 terms there. Minus 1 over a half minus 1. You just put this all in your calculator and you're going to get it's 120 minus 127.97. Right, let's look at question 5a. So we've got let's do sigma questions. It's not too bad. So it's a 5a and 5b, right? So 5a there's, we've got a sigma, and we just need, if it says calculate that, sigma means sum, sigma means sum, sigma means sum. So just calculate the sum. So, and how do I do that? Determine the first three terms. So term 1, term 2, term 3, and that will help you define a and define the ratio, right? So to calculate the first term, so it's going to be 1 over 50 and then 5 to the power of, and what's your bottom counter? Your bottom counter, it starts at 1, so it's k minus 1, and k is 1, so 1 minus 1. Do you follow? You substitute the bottom counter into k. So that's for the first term, and then you're going to work out the next one. So it's 1 over 50, 5 to the power of, and then it is, you up that by 1, 2 minus 1, and then it is 1 over 50, 5, and then you up that by 1, so it's 3 minus 1, and so you continue. Alright, so what we've got is, what is this equal to? 5 to the power of 1 minus 1 is 5 to the power of 0, so that's just 1 over 50. So that is 5 to the power of 1, so it's 5 over 50. 5 over 50 plus by, I like not to simplify it yet, I know it's a bit weird, I'm going to show you now. And then that is equal to 5 to the power of 2, so it's 25 divided by 50. So, why don't I want to simplify it? It's easier to see what the ratio is. The ratio there is equal to 5. Yeah, actually you can see it from there as well. The ratio is 5. And we know then the first term is equal to 1 over 50. But it's not wrong, of course, to simplify. It's never wrong to simplify. So, and then how many terms do we have? The number of terms is going to be the bottom counter, right? The bottom counter is 10. So it's 10 minus 1 and then plus 1. And which is equal to 10. Alright, so we're going to use the sum again. Sn is equal to a r to the n minus 1 over r minus 1. So the sum of the first 10 terms is a 1 over 50. R is, yes, you're right, 5. Well done, you guys. Well done, well done. And then 5 minus 1. Very interactive. So 1 over 50, and then, oh goodness, why do I still have an n there? N is equal to 10. There are 10. Oh, of course, there's 10 terms. So, and then what you're going to do is you're going to work out what 5 to the power of 10 is. I don't know what 5 to the power of 10 is. Not 5 to the power of 100. 5 to the power of 10 is equal to, oh my greatness. So it is 9765625 minus 1 over 4. And then you just to put that all in your calculator. So times that by 1 over 50, and you divide that answer by 4, and you're going to get 48828.125. Alright, let's look at question 5b. Again, you need to find sigma. There's a calculate, sometimes they evaluate. The word evaluate in mathematics is actually just do it. And so we need to find sum. In other words, sigma means sum. Sigma means sum. So here we go. So we're going to work out the first three terms. Term 1 plus term 2 plus term 3 plus. So term 1 is 8.5 to the power of n minus 4. Where does the bottom counter starts? The bottom counter starts at 3. So it's 3 minus 4. Right, so that's all term 1. Term 2 is the same story, but now that m increases by 1, right? So that will be 4 minus 1. Right, and then we've got 8.5, and then 3, 4, 5 minus 1. Yes, I can hear you. I can hear you. So what we've got is we've got 8.5. 3 minus 4 is minus 1. Plus, so 8. And please, do not multiply that 8 by a half. Seriously, you're going to get some disease. And there's no toilet paper in the shop, so if you get diarrhea, don't be angry. Sorry, I just see I made a silly writing error there. Those should be 4, right? It's m minus 4. 3 minus 4, 4 minus 4, 5 minus 4. Okay, so what we've got is we've got 8, so that will be a half. 4 minus 4 is 0. And then we've got 8, a half. 5 minus 4 is 1. So what we've got, what's a half to the power of minus 1? It's 2, so that will be 16. So that will be 8. And that would be 8 times a half is 4. And you actually know the ratio is a half, right? You can see there the ratio is a half. A is equal to 16. The ratio is equal to a half. Do we know how many n is? How many terms there are? It's the top counter again. Remember, top counter 11 minus the bottom counter, which is 3, and then plus 1. So n is going to equal to 9, right? 11 minus 7 is equal to 8 plus by 1 is 9. Okay, let's hit it. So Sn is equal to a r to the n minus 1 over r minus 1. So the sum of how many terms? 9 terms is equal to a, which is 16, r, which is equal to a half to the power of 9 minus 1 over 9 minus 1. You put this all in your calculator. The sum of those 9 terms is equal to 31.9375. Okay, so let's look at question 6a there. So question 6a, how many terms of that sequence, 64, 32, 16, will add up to a sum of blah. So what we've got is we've got a, which is 64, we've got the ratio there, again is a half, and we don't know how many terms, right? That's the whole idea. And we know the sum of a certain number of terms, which is 127 and a half, right? Okay, let's go for it. So Sn is equal to a r to the n minus 1 over r minus 1. So we know what the sum is now. The sum is equal to 127 and a half, right? Or you can write it as 255 over 2, right, is equal to then a is equal to 64, r is equal to a half to the power of n, we don't know what n is, minus 1 over a half minus 1. So first of all, so 200, I'll just do it in a couple of steps. So it's 64, and then it's a half, n minus 1 if you do it in a couple of steps, so that's minus a half. How do you get rid of the way of the minus a half? You times minus a half on both sides. So if you multiply minus a half there, right, what are you going to get? Yes, you're right. So you're going to get minus 255 over 4. Yes, you guys are just on it. So minus 1. Then you're going to, you can, let's multiply to all of that. You're going to divide 64 on both sides. We've got minus 255. Divide 64 on both sides. 4 times by 64 is equal to, what's that? 240, and 16 is equal to 256. 256 is equal to a half to the power of n minus 1. You're going to add the 1 on both sides. So 1 plus 1, then minus 255 over 256 is equal to a half to the power of n. Okay, what do I do now? What is 1 minus 255 over 256? It's 1 over 256. I kid you not. So therefore that is 1 over 2, so it's a half to the power of 8, right? 8 is equal to a half to the power of n, therefore n is equal to 8. So it's the sum of 8 terms that's going to equal to 127 and a half. Question, what is that? 7a. You need to find m, so this is the same question as the one before. It's now just in sigma form. Okay, so let's go for it. Sigma means sum, so you've been given the sum, right? That is the sum, and that part there, of course, is the general term. So in other words, work at the first 3 terms. So the first 3 terms, will be, that's his first three terms, I'm sorry. So that will be term 1 plus term 2 plus term 3 plus, so term 1 is 2 to the power of, 2 to the power of 8 minus, and the lower bound starts at 1, so it's 2 to the power of 8 minus 1 plus by 2 to the power of 8 minus, and then it goes up by 1, right? So it's 2 plus by 2 to the power of 8 minus 1 up, so that's 3, right, plus, so that will be 2 to the power of 7 plus 2 to the power of 6 plus 2 to the power of 5 plus blah 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 blah. So yeah, so that is equal to 128, 64 plus by 32 plus. Okay, so what do we need now? We've got, what do we have? 128 is the first term, the ratio is a half. You can also see that it's a bit in disguise, because look at that, it's 2 to the power of minus k. Okay, remember it is normally a r to the n minus 1, but now it is like a 1 over r. Okay, n minus, and then it's minus n. Okay, so just thought, but anyway, just do it from the first three terms, and we need to know, so n is equal to m minus 1 plus 1, right? Top counter minus bottom counter plus 1 is equal to m. Okay, and we know what the sum of those certain number of terms is equal to. It's 255 and a half. Let's go for it. So Sn is equal to a r to the n minus 1 over r minus 1. So the sum, I know what the sum is there, so that is 255 and a half is equal to a, which is 128. The ratio is equal to a half to the power of n, which is m, n. It's cleaning out his car closet. So minus 1 over r is equal to a half minus 1. Alright, so what we can do is, we've got, okay, 255 and a half, it's 511 rather, sorry, over 2 is equal to 128 a half to the power of m minus 1 over, and that is minus a half. So you're going to multiply minus a half on both sides. So minus a half times by 511 over 2 is equal to 128 a half to the power of m minus 1. So that is minus 511 over 4 plus is equal to 128 a half to the power of m minus 1. So you divide by 128 on both sides, and 128 times by 4 is equal to 512. So you get minus 511 over 512 is equal to a half to the power of m minus 1. You add 1 on both sides, same story as the previous one, so it's 1 minus 511 over 512 is equal to a half to the power of m. So that means it's 1 over 512 is equal to a half to the power of m. So 512 is a half to the power of 9 is equal to a half to the power of m. So therefore m is equal to 9. Alright. So Mr. Deeds gives his son this last question, R1 on his first birthday. $1, sure. And then R2 on his second birthday, R4 on his third birthday, R8 on his fourth birthday, and so forth. Alright, so hopefully it's going to be alive, Mr. Deeds, for some while. How much will he give his son on his 18th birthday? Okay, so how would that work? So if you form a sequence, it will be 1, 2, 4 each time it doubles. All right. So on his 18th birthday, how would you write this down? So it's Tn is equal to a r to the n minus 1. All right. So Tn is equal to a, which is 1, doubles, and then it is n minus 1. So term 18 on his 18th birthday, he's going to get 18 minus 1, and that's quite cool. What is 2 to the power of 17? 2 to the power of 17 is equal to, so it's 131,072 rand. It's not bad, eh? Yes, to get that on your 18th birthday. So you can buy a lot of calculators. Okay, so let's go 9B. Or maybe you can start anti-emoji movement. You know, I'm sure that organization, the anti-emoji organization, needs some funds. So please just give them funds. Those emojis need to fall. Please, man, come on. So, question 9B. So, find the total amount of money that he will have given him by that stage. Okay, so now we need to find the sum of all the money given, the total tally, the cumulative total. Up to his 18th birthday. Okay, including his 18th birthday, of course. Okay, so in other words, it's the same general term, right? It's the same amount of money per. So this is on his first birthday. This is on his second birthday, and then 4 is on his third birthday, and 8 is on his third birthday, and so on. So in other words, the sum then is in r to the n minus 1 over r minus 1. And the music stopped. And the sum of how many birthdays? 18. And a is equal to 1. The ratio is equal to 2 to the power of 18 minus 1 over 2 minus 1. And then if you type that in your calculator, you're going to get 262,143 rand. So up to that age, he's received 262,143 rand from Mr. Deeds.